Hello there, welcome back to my channel. Today I'm very excited to build and share this model, Sigma. It's you can think of it as a function or slope generator in the domain the same as Mats from Necknoise or Rampage from Befaco. This one has a little bit of my character inside, and it's based on very old designs from Serge again. The simplicity attracted me and the functionality. The switching of the CV modulation as a performance tool quite excites me quite a lot. Actually, also the volt per octave tracking and the filtering ability. This model can do so much. You've probably already seen some kind of version of it as well, but this one is a do-it-yourself project. You can go to my GitHub repository, which I'll leave the links below. I'll always make the building videos, the calibration and some demos, but I also have a lot of documentation on these repos, so you can just follow along. I have an AutoCAD file. If you happen to use Tide online shop, you just click checkout, you get the components. I have the Gerber files, which think of it as zip files that you upload to any online PCB manufacturer, and you can order your PCB to your home yourself. So you don't need me to build this module, and it's great to experience the end-to-end goal of building something, so I totally recommend. And it's gonna be very cheap. If you're not in a hurry, the shipping costs, as you know, depend on that. If you can wait 2 weeks, 3 weeks for something, it's gonna be really cheap build for you and super high level functionality. So let's build it together today. I hope you enjoyed the video and the model. Have fun. See you soon. Thank you. So we're gonna start our build of Sigma function or slope generator with a couple of great outputs and modulation to play around with. Based on the very old design of maybe the first slope or function generator from years and years ago. It has a little switch, so you can modulate either the rising or the falling of the wave. It's quite an interesting approach that I liked, and also tracks volt per octave, which is quite cool to have in a model like this. So I'm gonna print the boom file, I'm gonna put it in front of me. We're gonna start with the control panel, then we're gonna do the main panel and the front panel, which connects everything together. This time I'll try the sandwich approach by my friend, My Modeler Journey, to which I'll leave some links in the description. He has a great channel as well of DUI synthesizers. Let's see how it goes. So let's get started with the control board. So I always recommend using something to hold your PCB. I find this device quite useful. I don't remember the name right now, to be honest, but I try to leave a link in the description where you can see how you can get one of these. It's quite useful. You can rotate it around, you can keep it stable. It works quite well for me. So as always, as I do when I solder one of these, I'll start with the smaller components, the resistors, bend them down, put them all on top of the PCB board. Then I will just give a little notch of solder from the top view just to hold them together. I will rotate the board and finishing the soldering process and cut the legs, and that's pretty much it. And I'll do the same for diodes, capacitors, and then for the big user interface elements, we'll connect the front panel to make sure they all stick together while we solder them. So we're gonna start doing the user interface elements, you know, the knobs, the switches, the input jacks. And the way that I like to do this to make sure they are aligned with the front panel is put them all in the position, meaning on place in the board, in the PCB board. Then I will connect the front panel, tighten it up a little bit on the edges, maybe just on the edges. And then I will actually solder the components from the back. And then I remove the front panel again if I need to, but this way I make sure that they all in the right place from the beginning. So let's talk a little bit about the LED. There's also a LED that you're gonna solder here. For now, we're just gonna mount it and solder from the back. This LED is supposed to be in touch with the front panel. The front panel should be built off of the same material as the PCB. It's called FR4 material, which will reflect light. So the idea is that the LED is projecting into the back of the front panel light that will also be shown through the front panel as well, through the small assets, like a small image that I have on the front panel. So for now, what you need to understand is that you need to solder the LED in a way that the head of the LED is in touch with the front panel. But that's okay, that's why we're adding these elements now on top, and then we're gonna add the front panel and put everything in position first before we solder, so nothing to worry about. So now let's move to our main board. I usually call main board the board that contains the logic for the system to work, and the control board, which is the board that contains, the knobs, the inputs, the jacks, so on. So let's do the main board now. The process that I follow is always the same. I always start with the resistors. I put as many as I think it's okay to start soldering, like groups of 10 or 15 maybe. And then I'll give a little notch of soldering on top, on the legs, just to hold them together. Be gentle and careful, of course, to not touch the component with your solder iron, so on and so forth. Make sure you take your time, be patient. And then, I'll just rotate the board, finishing the soldering on some missing spots on the back, cut the legs, and that's pretty much it. Then I'll go through the capacitors, diodes, from small to big as always. I always try to keep my board clean of dust, at least. I just want to make sure, I had some surprises in the past, let's say that, by letting a missing piece of soldering around. Anyway, that's not important here. So now we're gonna solder the power connector. This is really important. I really want you to remember this. This connects in the back through your power supply system. And this is the only element on this board that you need to solder in the back. Just see here how I'm doing it. I'm putting it through the back. Seems everyone has their own system for this. My system is like to hold it with one finger in one hand, rotating around a little bit, solder the two edges, so just to keep it in place. And then once it's secure in position, I will solder the rest. I've seen many different approaches for this. You might just put it on top of the table, for example. Whatever works best for you, I will say. Now we're gonna solder a couple of transistors in the main board as well. Just a note on these guys, I'm using a different footprint now. It gives more space between actually the soldering holes, which means less risk of contact or short circuit. That's one thing. The other thing is make sure you always leave a space between the transistor and the PCB board. Transistors are very sensitive to temperature changes, so just give them some room to breathe. That's all. So finally we are reaching the last part, almost the last part, in this case the IC components, the integrated circuits. We have two on this board. I always make sure I use sockets, meaning you will put the IC on a socket and then you solder the socket to the board. This way you can replace your IC if there's something wrong or something faulty. Believe me, this happened to me recently ago where I had a socket and the IC was mounted on reverse and I turned on the module and smoke starts coming out. And actually I could just switch the IC for a new one in the right position and everything worked perfectly. So I cannot say how much this is useful, having a socket instead of soldering directly IC to the board. And that's pretty much it. All that's left to do is connect all boards to our sandwich test that we'll do today. It's a simple build, but a delicate one, because as you can see, components are very close together. I wanted to make this as small as possible, and but without interfering on the user experience. I don't believe in micro knobs or small knobs. I want to have space to interact with my instrument. So just be careful and gentle with your soldering. Not a lot of components, but a lot of different components, which makes it, time consuming. What I recommend doing, what I personally do, I put a box aside like a couple days before maybe with a component from the BOM file that you can check on my GitHub repo, linked in the description below, of course. And I will prepare a box with the components for this model. So on the day in the soldering, I know I have everything I need to build this model inside the box, and that makes it easy for me. Organize it a little bit. That being said, it's not a complex circuit, it's a delicate circuit and very functional and small sizely, not tiny, but small and very playable, as you will see in the demos ahead. Here we're just finishing with these two trimmers. They are on the side, so you can actually calibrate while it's still on. You just need to lift the model a little bit from the rack. One is to calibrate the bipolar output. The other one is to calibrate volt per octave tracking, which we'll demonstrate a little bit ahead on a calibration video section, and then we'll see some demos as well, of course. So for this model, to connect my models, I usually use the same approach, which is these female and male pin headers. Here is a 10-hole header from each side. Just don't do what I did on the beginning and solder the headers on the reverse way. And then you'll try to connect your front panel to your control panel. Yep, not a good history. So here I'm just preparing the pins, and then we'll try the infamous sandwich method for my partner in crime, my modular journey. Let's see if that makes it easier. So let's start to connect these pins first without soldering. We're gonna basically do a sandwich with these two boards, and at the end add the front panel as well, of course. But for now we're gonna try to connect these two without soldering, and then we're gonna solder the pin headers in place, meaning we don't even have to worry about if they will be in the correct position or not. My first approach of this method, fingers crossed, let's see how it goes. So it's sandwich time now. Let's connect these two boards. It's a bit tricky, as you know or don't know. I have a shaking condition, which makes it more interesting to me. But but I can do it. Let's do it. Let's do the sandwich and then put it on top of the table and just solder them in place. There we go. It seems we have a sandwich in place, out of the oven, ready to go. Okay, that wasn't that hard as I was expecting, so okay, let's see how the next part goes. I'll just put it in place and solder the headers, and let's see. So looks like we are done, just cleaning up a little bit. This method has been approved for me. Actually much faster, much better than how I was doing it before. So thank you for that, my modeler journey. Just gonna mount the front panel now. It's looking good so far. I'll always pimp my model with these bifaco colorful thingies, and I just use a simple color scheme. Black is for input, red is for output, that's all. Doesn't matter what kind of input or output. In that aspect, I like to follow the Serge philosophy. Signals are either input or output, that's all. So let's mount the front panel and let's do calibration. Calibration is really quick, just for the bipolar output and volt per octave tracking, and then we'll jump to some demos. So let's start to calibrate our model. It's not that hard, it's gonna be a quick, just adjusting the bipolar outputs and a little bit the volt per octave tracking. I didn't care much about the volt per octave, but still there's a trimmer in the back if you want to adjust it. So the first thing, as you can see, is that the model is oscillating by itself as soon as you connect your board. I wanted the design to be like this. I wanted to be oscillating. You will stop, you will interrupt this cycle mode as long when you connect something to the trigger input, of course. So here with the trigger, you can see we're generating a ramp. We can use it as an envelope, for example, or to modulate anything else. You'll notice that these potentiometers are not normal. I just wanted to try algorithmic potentiometers here. So you see I have to move quite a lot to make a longer cycle. But on the boom file, you'll have 3 linear potentiometers. This is just for me to try it out. I want to see how snappy I could get with it. So here you can see it's oscillating on a bipolar mode. And you can see just with the rise and the falling of the ramp, you can define the kind of wave that you want. You can have saw waves, you can have square waves, you can have triangle waves. This can be an oscillator as well. I intend to use it most as a modulator to other oscillator, but it can perform quite well as well. So let's adjust the bipolar output. You see here this trimmer. A small adjustment go a long way. These are very sensitive trimmers, so you can see hear me moving. So I'm just gonna calibrate it, gonna make it the same amount of positive voltage as negative voltage, and that's pretty much it. It's quite done. So this was the bipolar output. Here we have the AC coupled output, and then you have a DC coupled output. So 3 different outputs along with 2 other logic outputs as well that you can choose. A lot of functionality on this small module. So let's see what this model can do. Let's start by hearing some outputs here. We're listening to the bipolar output now. And I'm sending a pitch sequence to the volt per octave input. So we're gonna calibrate the volt per octave a little bit and see what we can get of it. Again, the volt per octave, the tracking is not perfect. Maybe something to consider for a second version if I want to go that way. But for now, you can get it stable, let's say between 2 octaves, I would say. So the calibration of volt per octave typically is the same on any kind of oscillator. You measure 2 octaves or 3 or 4 or 5 if you want to, and you keep adjusting the potentiometer, on this case a small potentiometer on the back, so that the interval between the notes it's closer to the real one, so you can have better tracking. I'm just gonna coordinate and I'm just gonna synchronize it a bit between 2 octaves. That's perfectly fine for me for now. So that was it for the calibration. As you can see, nothing special here. I'm excited to go into the next video for some demos. Please stick around if you want to. The next video should jump automatically. If not, just pick up the demo videos for the Sigma model. I hope you enjoyed, and I hope you can have a chance to build it for yourself as well. Thank you, and I'll see you soon in the demos.